number of classes you want.
Okay.
And of course you round if it's
So I think that's 13.1666. I don't know.
14.8.
14.8? 8? All right, I can live with that. And then what would I do with that? That can't be true.
Oh, no.
No,
That's not it.
it's 13 points, what I said, isn't it?
Okay, yeah.
13 point, I should stick to my guns.
Yeah.
0.16.
Yeah, 1666. So then I round that to?
13.
No.
No, 14.
And why? Because again, remember, it's about like covering a wall. If I round each panel's width down, am I gonna still cover the whole wall? No, there's gonna be parts of the wall that don't have anywhere to go. Right? So I have to always push it up, because the main point of it is every data point needs to have a place to go. If I round it down, the last data points are gonna be like, oh no. Maybe?
How would you ask, like on a situation like this?
Just like I did on the practice test.
Oh,
Construct a thing and show your class width.
okay.
So it's fine if your final class has a wider range than your actual high?
Oh, yeah, it doesn't have to end at the highest number. Yeah, because this could have been a 91. It shouldn't suddenly change the width, right, of the last class. It might change the width of the whole thing. So what would my classes look like? I have way too many people doing something like this, starting at 5 or something. The problem I gave had a 4 here and people were putting a 1 here. That makes no sense. You're gonna almost definitely have to have one more class than you want.
So you start where
You should always start at the lowest data point. You could start at 10, but why? So this is 11, so what's this number below it gonna be?
25.
Good. So what's this number gonna be?
39. Wait, no, hold on. 24.
24.
I'm
Right.
saying that.
You gotta be able to see the width this way.
Yeah.
Because this way the width is hidden. What am I gonna do when I go to make this? It's gonna be from 10.5 up to 24.5. 10.5 to 24.5 is 14. So the width is hidden this way, but you can definitely see it this way. And again, that's the textbook method. When you do that weird ass shit, you gotta deal with that. I gave you the other way to do it, but if you're not good with inequalities and stuff, then you don't want to do it the other way, I understand. And then you just keep adding 14, keep adding 14. Okay, maybe. Yes.
Can we go through how to do like the histograms?
Okay. So let's see. All right. There's some data. And I've already put it in order for us. That's nice. How do I get the width, the class width?
highest minus the lowest
Yeah, the highest
divided by
minus the lowest.
divided by 5.
Yeah, we'll do 5 because it's a very small set of data, so I'll use the least classes. What's that? What is it? 5, okay. I don't need to do anything to it, so I'll show you what's going to happen. There's one little weird thing that's going to happen, and it's acceptable. When you get a perfect outcome for the width, something weird's going to happen. I'll show you. Might be why I made it like this. So how do I start my classes off?
4,
Yes. So where's the next one gotta start?
5,
5 later. So 9. So what's this one gotta be? 8. So then I just keep going by 5. Now notice what happened. What happened here?
you missed it.
Ah, good. So if this comes out to a perfectly whole number, you're actually allowed to make this last one. You effectively just suck that last data point in. That's the one time you could do that. Yes.
So it was fine for that one to be 6.
For this one case. Because that's where you have just one data point sitting right next to the class, you might as well just suck it in. Okay. That's the way it is. Now.
Then yes, do the sum.
No. Well, how do what's this column going to be? Frequency. So what's going to be 4 through 8?
4.
4 of them, right? 1, 2, 3, 4. 9 to 13, 1, 2, 3. Is everybody with so far as I guess?
Yeah.
And then 14 to 18, 1. 19 to 23, 1. 24 to 29, 1, 2, 3. How many data points do I have now? 1, 2, 3, 4, 5, 6,
Then you add
7,
some.
8, 9, 10, 11, 12. And thank God these add up to be 12. You should do that check. Right, if they add up to 11, you left somebody out, everything's going to be thrown off. Thankfully, you got an instructor that grades partial credit. So you'll only lose points on the part you make wrong. If you do everything right after that, you won't lose more points. Does that make sense?
But when you get a different answer if you do one thing wrong?
Of course you will. But I will grade the rest of the problem assuming it's right. So you lose points on that one thing. If you do everything else right, you're fine.
And if for your standard deviation, how do you always
Wait. We're nowhere near standard deviation right now. We're just making a histogram. Right? This is not the standard deviation table, is it? It's a frequency table. What am I going to do next?
Relative frequency.
Relative frequency. The real freak.
Divided by the 12.
Yeah, so 4 divided by
12.
and then 3 divided by 12 is nice. And then 1 divided by 12 I think is 8.3.
Yep.
And then 3 divided by 12 is nice still. And then if you add those up, you actually get 99.9. You guys see that?
Mm-hmm.
Why is that okay?
Because they're rounding.
Yes, close enough to 100. I happen to round down more than up,
So we.
right?
Just a quick question. How do you get the 5 on the class with?
Like this.
This is the next
Yeah.
one.
So the formula is high minus low divided by number of classes.
Oh, that's number of class. Okay.
Yes. I like it.
And which can only be 5 or 6, right?
Well, 5 up to 10, but for us, I'm not going to give you enough data to make it worthwhile to do 7, 8, 9, 10. Right, I'll use 10 if I gave you 1,000 data points. You don't want me
No.
to do that. Yeah.
I've done that before, so.
Good so far? Okay. And then when I go, we already said this, but when I go to construct the histogram, how's the scale on the x-axis going to look? Oh, I forgot to change this, but we'll do.
3.5.
You go half a step down or each.
Mine is in half.
Yep, good. So it's going to be, start at,
3.5.
and then I just keep adding 5.
So
8.5, 13.5, 18.5. What did I say?
I don't know.
20.5.
Something. I don't know.
Should the last one be 29.5?
Yes, thank you. So the last one, you do have to capture that 9.
Yeah.
Kick ass. And then what scale should I use going this way? The highest I gotta go is 33. We do use this a lot. Maybe scale by fives.
Yeah,
right?
do it all the way to 35.
Yeah. 5, 10, 15, 20, 25, 30, 35. You're getting too many people that do 5, 10, 20, 30. Because you've already established it's 5 and then suddenly it becomes 10. So your scale has to be consistent.
Yeah.
Always. I don't care what class you're in.
Yeah.
And then you just make, and now this is the easy part. Here's relative frequency. Did it say what these were? No. So numbers from Jeff head. Right. But you always gotta label it with what it is physically.
Yeah.
This is always gonna be either frequency or relative frequency. You can write RF, that's fine. And then you just make, now that's the easy part, right? Go up to 33, 25, 8.3 for the next two, and then 25. So does that look normal?
No.
Hell no. Looks the opposite of normal. Looks like somebody's telling me, dude, alright. Dude.
I know.
Or not. At least it's not flipping me off. That's what a normal curve would look like, is it's flipping you off. You got everybody alright with that? Histograms are not difficult. They're just very different from stuff you've done. Right? So I understand that part of it. Setting up the classes always trips us up. Just make sure that when you look how this has got to equal that, this has got to equal that, all the way through. Unless, that one thing happens. I normally try to make it so that that doesn't happen, because I agree it's a little weird that this is allowed, but it is allowed. So I do kind of pick data, so the high and low is sort of not going to come out to a nice number divisible by 5 or 6 or something, to help you. You're welcome.
Do you have time to do the second question?
Yeah.
Yes.
Let's see.
Great.
What is it?
The practice test,
Number 2.
number 2.
This textbooks?
Yeah.
Oh yeah. All right.
Is it a formula?
So this is exactly like the book, the homework in 2-7. So this is really just, now watch. This is going to seem kind of silly. In class, I very often will call standard deviation steps, because which one of these, I'm building up to your question, by the way. Which one of these has a larger standard deviation? This one. So standard deviation, so maybe this one would be, here's one step away is here, but this one step away would be here. Because it's got a bigger standard deviation. So I call them steps because I want to step around in my data, right? So if I use too big of a step, all my data is gone. I've missed it all. So I call them steps. It's how we get around in our data. So the tighter my data is, the smaller steps I want to use, so I don't miss anybody. Does that make sense? So in class, I will sometimes refer to standard deviations as steps. It's got the same first 2 letters. That's a bonus too. On your test, don't refer to them as steps in an official answer, right? I like it. But I like to think of them as steps. So let's say that I'm standing at 11. Mark 11 somewhere. And I want to go, well, you remember this one was, because I gave you 2 different ways. Oh, okay. And I want to know, and every step I take is 3.5. So what number is 2 steps up?
7.
That's going to be used. 2 steps up is how far?
2 steps.
2 steps up is how far? 2 of these. I heard it.
3.5 times
It's 7,
Yeah.
right? What's 2 of these?
7.
7, right? So let me make this a little more like 2 standard deviations. How big is 1 standard deviation?
3.5.
So how big is 2?
7.
7. Where do I end up if I go 2 steps up?
18.
18. So what did we do? We did 11 up plus 2 of these. Start at 11, go up 2 of these. I like it. So if I wanted to go down 3.4 standard deviations, what would that look like? Start 11, go
You go
minus down
3.5.
3.4 of
3.5.
these, and whatever the hell that is.
Yeah.
Again, you might not believe me, but you've got to get to the point where you can see this. It makes complete physical sense. That's why I like to call them steps, to make what we do with them make more sense. If I start here and I go 2 steps up, well, it's going to be 18, because every step is 3.5. I mean, that makes physical sense. And that's exactly what we do in statistics. And then whatever the hell this is, I don't know. Maybe I won't ever know. I'll get over it. Okay, I'll never know. Okay. So you would just do 11 minus 3.4 times 3.5, whatever the hell that is. 7, 11.9. Is that negative 0.9?
Yeah.
Okay, nobody will tell me, but they will verify. Okay. Anything else, you guys? How many of you guys have tried out the Math Study Center? Anybody? It's okay if you haven't, but you have. Okay. Is it going okay in there? Sometimes some tutors are a little less sure. You got to make sure. You can always tell them, hey, can I just wait for somebody else or something? And if they're really not sure, you should really leave an evaluation, right? Or if they're really good, you should leave an evaluation.
I feel like sometimes when I go, I feel like more lost. And when I learn it, like,
You're-
I feel like I get more lost and more confused because they explain it a certain way, and then you understand it and it becomes a class and then you do it this way. And like,
So there's an idea that can be explained in multiple ways. It's kind of good to get the explanation in a different direction because then you understand the basic idea better. But I understand when you're first learning something, you want a repeated message. I get that. And that's why you should bring your notes with you and let them look it over because every teacher's got kind of a different way of explaining things. I don't know if any other teacher calls standard deviation steps, for example. I know it. Huh?
my class professor when I calculate stats.
Called it steps?
Call it steps.
Sweet.
And then he did like he made us do like 90 something points, and he made us do in a calculator. And for our first quiz, it was doing inserting all the points inside a calculator and making sure you don't miss any, and then you must put them in order.
Yes.
Because if you don't, then your whole frequency is evil.
There you go. So you got a lot of practice with that. I like that.
Yeah, but that's why they passed the class to number 2.
It's almost time. Yeah, don't freak out. If you got what you need, you can leave. You don't have to sit there.
I have a more specific question. Would you take that if I'm trying to find the number of standard deviations? I just
Oh, sure. But now you've got that. It's that x minus the mean divided by. That's we did number 2. Number 3.
It's like you're trying to
is how
find how
many-
many of those are there.
Yeah. So that is going to be whether z-squared's eligible.
Okay. I just kind of came up with my
You
own.
ready
Is
for
that
this?
okay?
Watch. If I solve for x,
Mm-hmm.
don't I get s times z plus x bar?
Yeah.
Isn't that what we're doing here?
Yeah.
Yeah.
Do you want me to use that exact formula or what I
It
have
doesn't
here?
matter. Algebraically, it comes out the same way.
Yeah.
And we're going to get more used to that equation later anyway.
Okay, so
Yeah.
I might as well start using